Nice!
We probably overdid it.
Yeah.
So sometimes less is more, which is why today we will be investigating how large an evaluation dataset should be for a use case study on the universal dependencies. So some downsides of too large evaluation datasets is that we are missing out on training data because we're using our data for evaluation, or we are limiting our coverage. You can imagine if you annotate smaller dataset, you can annotate more languages and or domains. Furthermore, of course, you have to pay more or use more time if you want to create larger sets. So our setup is as follows. We will compare 33 multilingual language models for dependency parsing. So we're using a deep widen parser with a multilingual language model as an encoder. And we will use 50,000 words for training, and we use the rest of the datasets that we use for obtaining a gold ranking. Then we will make this evaluation set smaller and try different sampling strategies. And we will compare the rankings obtained with these smaller sets to the gold ranking. And we will use Kendall's tau for comparing the rankings. In the paper we also checked with significance testing, statistical significance testing, but it gave very similar results as Kendall's tau. So for computational reasons we focus on Kendall's tau for most of the experiments. These are the splitting strategies that we have investigated. So first we have the sequential one, where we take the first chunk for training, this is indicated with the T here, and then we take the last chunk for development, indicated with the D. And here the idea behind this is that we pick the last ones because they're most distant to the training data. Then we have the random strategy, where we pick random instances from the dataset until we reach our desired size. And random sequential, where we pick a random point in the data and from there we pick a sequential amount of instances. These are the datasets that we have used. So we mainly try to find datasets that are quite large so that we can try with a variety of sizes and obtain a good gold standard. And we wanted to have this cross-domain and cross-lingual angle as well. So that's why we ended up with the news and the web domain and English, Italian and Russian. These are the main results on our in-tree bank experiments. So we can see here that on the y-axis we have the Kendall's tau, and on the x-axis we have the development data size in number of words. You can see that if we pick the sequential strategy, we already have enough evaluation data at the point of 1,000 to 5,000 words. So for the other strategies, it's a bit more mixed, but in general, from 2,000 on to 5,000 we obtain a very good ranking. This also shows that the sequential strategy that is most distant to the training data seems to be a good sampling strategy. These are the cross-domain results. Here we can see generally lower performance. So we need more data to obtain a good ranking. This could be also due to the fact that we have the cross-domain angle, where models perform differently, of course. They usually perform lower on another domain. But there's also the annotation that can differ across different tree banks. Then finally we have the cross-lingual results, where we have a more stable picture. There's a slow tendency to increase here. And in general we can see again that between 1,000 and 5,000 we obtain competitive enough ranking, but here we are not harmed so much for picking even smaller sizes. So cross-lingually the performance differences are larger across the different parsers, which is why it's easier to obtain a competitive ranking. So these were our main results. Thank you for listening, and all our code and predictions are publicly available. Bye!